So now we have the Krebs cycle, and this takes place in the mitochondria in the matrix. So what we have here is acetyl-CoA, and this is the products from the link reaction. So acetyl-CoA is a 2-carbon molecule, and what we have to do is we have to add a 4-carbon molecule onto it, which is oxaloacetate. So these ones have 4 carbons, and when these come together, they form citric acid. And citric acid is a 6-carbon molecule. So it's important to know that citric acid can also go through decarboxylation and go back to oxaloacetate. So how this happens is it loses 2 carbons, and then it becomes the 4-carbon molecule, which is oxaloacetate. And this keeps happening back and forth. So acetyl-CoA and oxaloacetate combine to form citric acid, and then citric acid goes through decarboxylation to become oxaloacetate to produce the hydrogen or electrons that are formed when the bonds are broken. So during this cycle of oxaloacetate becoming citric acid when it's combined with acetyl-CoA from the link reaction, when the citric acid is decarboxylated and the 2 carbons break off, the carbons each form CO2. And then also as the carbons break off, hydrogens with electrons are also broken off, and these electrons and hydrogens are what are needed for the electron transport chain. So that's why this cycle is continuously happening. So during this cycle, as the electrons and the hydrogens are being broken off, NAD and FAD have to pick them up. So the end products of the whole Krebs cycle are 6-NADH, because the NAD picked up all of the hydrogens. So the NAD becomes NADH. And then the FAD also picked up hydrogens, so it becomes FADH. So we have 2 FADH, 6 NADH, and then we have 4 carbons that were made and 2 ATP. And those are the end products of the Krebs cycle.